Alright, so an identity is an equation that says two expressions are equal for all values of theta. An identity is always true. That's why we call it an identity. Okay, it's always true. So we're going to start verifying trig identities today. We're going to show that both sides of the equation are the same thing for all values. Okay, for any value that's defined, it's the same thing. So let's start for just a second with this, and let's use pi over 6 as theta. We're going to show that both sides of this equation are the same if you use pi over 6. So we've got the secant of pi over 6 minus the cosine of pi over 6. And then over here we have the sine of pi over 6 times the tangent of pi over 6. What's the secant of pi over 6? Look at your unit circle if you have to.
Square root of 3 over 2.
Yes, so I'm going to go ahead and just write it as 2 over the square root of 3. What's the cosine of pi over 6?
Square root of 3 over 2.
So I'm going to multiply this side times 2 over 2. Multiply this side times square root of 3. 3. So this is 4 over 2 square root of 3 minus 3 over 2 square root of 3, or 1 over 2 square root of 3. Alright, over here, what's the sine of pi over 6?
1/2.
Times the tangent, which would be the sine over the cosine.
1/2 over.
Yep. Or we're looking at 1/2 times 1/2 times 2 square root of 3. To equal 2. So we can see, if we did all that, we can see that they are equal. They have the same value for one particular value of theta. My leg's stuck. Okay. Okay. So now we're going to go down here and we're going to take away the value. Because just because it works at one value doesn't mean it works at all values, okay? There is something that written here that we're going to talk about. Basically, this means that the left side can be written as the right side can be written as the left side. And then he adds, or both can be written to form a separate equivalent expression. That's really not accepted, okay? You can do it to kind of help you get to where you need to be, but generally we make the left look like the right or the right look like the left. You only work with one side. So you pick the side, I generally pick the side that's most complex and try to make it look the simplest. So like this right here, this is the one that we just had with the pi over 6, okay, right here. So what I'm going to do is I'm going to try to rewrite this so that it looks like that, okay. First thing you do, rewrite everything as sine and cosine, right? So instead of secant theta minus cosine theta, what's that going to look like?
1 over the cosine theta minus cosine theta.
1 over cosine theta minus cosine theta. I'm going to multiply this one times cosine theta over cosine theta to try to get a common denominator. So I have 1 over cosine theta minus cosine squared theta over cosine theta. Alright, what does 1 minus cosine squared theta equal? Right, that's sine squared theta. Oh my gosh. Fixing to choke my kid out.
Which one?
The middle school one. Walk her in the garage. I could. Alright, now, I need it to look like sine times tangent. And right now I have sine squared over cosine. So what I'm going to do is I'm going to, okay, you have to be a little bit intuitive. You have to know where you're going. And this is where I'm going, okay? I'm going to split up sine squared. I'm going to have sine theta times sine theta over cosine theta. Because what's sine over cosine? Right. So now I have sine theta tangent theta equals sine theta tangent theta. Yay. Now, this is not the answer. We knew the answer when we started. We knew we were trying to get to here. This is your answer. The work is your answer. Okay? All right, let's look at this one. So you just have to decide which side looks more complex.
The left side.
Yeah, I think this side probably looks more complex. That side, it's not so bad.
If we have this on the quiz, something, this is probably for response, right?
What would be the multiple choice questions?
It could ask you about a step
That's what I was thinking.
or something like that, or if it's legal to do or whatever. So what we're going to do is we're going to change everything over here. Cotangent is cosine over sine.
So does that sine cancel?
Yeah, and I'm left with cosine theta over cosine theta. So you might be tempted to go, well, that's just 1. But that's not what and you're right, it is. But really, that's just 1 also. My end goal is to make it look like this. So I'm going to split it up to 1 over cosine theta times cosine theta. That's the same thing, it just looks different, right? And what is 1 over cosine theta equal to? Secant times the cosine of theta.
So it's just knowing how to split it up is what the difficult problem.
You know where you're trying to go. You just don't know how to get there sometimes. Yeah,
Yeah.
exactly.
Sounds like a life problem.
Right? And this is an allegory for your life. Hey, what looks tougher over here? Right side or left side?
The right side.
Yeah. That right side looks really hard. No.
The left side.
This one's not too bad, actually. Let's start with this side. What'd you do first, by the way? Did you distribute or did you change everything to sine and cosine?
Change everything with sine and cosine.
Okay. I can do that.
Isn't that the rule?
Well, you have to do them both, so it doesn't matter. Like, they both have to be done, so it doesn't matter which one you do first. Do that too soon. I have a lot. Hold up.
I see what she did.
Okay.
You did there was distribute, right?
Mm-hmm. Yeah, that was just distributing. So I still have cosine theta, sine theta in my denominator.
You multiplied that first, right?
What? Huh?
You multiplied that first, the, what's in the parentheses? Or did you just?
I did it all in one step.
Okay.
Yeah.
So.
You could do it either way, right?
Yeah. Don't cancel anything just yet. Well, I don't know. If you're past me, you can cancel.
I'm just confused. After the minus sign, like second step, how'd you get?
Here?
Okay, under that.
Uh-huh.
Back to the right. How'd you get that? Yes.
Cosine times cosine.
Okay.
Cosine
so
squared.
You don't distribute, like, you don't.
I've distributed this.
Okay.
That's how I got a cosine and a sine in the denominator.
Yeah.
And I don't want to cancel out these cosines because right now I actually have myself a common denominator, which turns it into this.
And then once she distributes all three things, that's she just asked her yesterday. It's just one thing.
Yeah,
She
you.
distributed
first
and
thing?
then she multiplied.
Yeah, because look, if you had, think of it like this. If you had 2x times 4x plus 3xy, that would become 8x squared. That becomes 6x squared y. I don't multiply 2x times 3, then 2x times x, and 2x times y. That doesn't happen. And that's what's happening right here. These are just being multiplied. Yeah, so it just goes to, this is a factor. That's one factor. So it just goes to that one thing.
I got it right.
All right, so then what does this become?
Sine squared theta.
This is sine squared theta over cosine theta, sine theta. And now I can do some canceling. That's gone, and I'm left with one of those. And sine over cosine equals tangent.
Okay.
All right, let's see. Let's skip this one. Let's do this one. This one's a little bit uglier. Hmm? Well, see if you can start it without me, and then we'll work on it.
Which one?
This one. Which side do you start on? The left? Okay. This one can be done in like a half a step if you use both sides, by the way. Alright, did you get here? What did you do after this?
That's as far as I got.
That's as far as you gone?
I don't go after. I think put equals 1, don't think.
You can go to that equaling 1. You can use a trig identity. A Pythagorean identity, I mean. What's Pythagorean identity that uses secant and tangent? Go to that very first page. 1 plus tangent, what?
Squared theta equals secant squared theta.
So 1 plus tangent squared theta equals secant squared theta, right?
Yeah.
Okay, so that would mean one would equal secant squared theta minus tangent squared theta, right?
Right.
So if you got to 1 here, then you could just use your Pythagorean identity. Just took up space on the next block. Well, that's good. I feel set.
For the quiz, we're going to have those memorized.
Yeah, you'll have to know them. I think you'll probably know them anyway by then because we'll use them so much. But you'll have to have those Pythagorean
So
identities.
for justification is the
If you could use both sides, this is one that you can substitute right here. You could have said, well, that is equal to 1 plus tangent squared theta. And then you've got your minus tangent squared theta. So those cancel out. So you've got 1 equals 1. But you really need to stay away from using both sides.
right.
You really need to just try and get one side to look like the other. That's just what we do. I mean, that's just how it's done. So, anyway. If you change this one to sine and cosine, you end up with 1 minus cosine squared theta over cosine squared theta. No, you don't. 1 minus sine squared theta over, which is cosine squared over cosine squared. So you get back to that being 1 again. So both of these sides equal 1. You just have to get to that. All right, let's look at some uglier ones. Look on this page 628. They get uglier.
This is our last page.
Yeah. Alright, on this one, since this has to be foiled out,
Use the right thing.
yeah, make the tangent look like that.
Yeah.
No, I'm just kidding. I would foil that and then change it to all those fractions because you may get lost in the fractions. So I would do the foiling and then do the fractioning. I'm going to give you just a second to work on it, and then we'll work on it together. Alright, does your first step where you foiled it look like that?
I can't
Okay.
even see it, so.
Okay.
What did you forget?
Secant theta, cosecant theta, minus secant theta, cotangent theta, plus cosecant theta minus cotangent theta. Okay, great. Alright. Bless you.
It's very ugly once you put all the fractions in there.
Yeah, well, can you
Cancels out.
imagine multiplying it as it being all those fractions? Cosine theta over sine theta plus cosecant is 1 over sine minus. Let's see, so that's 1 over. Have you gotten this far? Yes, no, maybe?
No.
I have a question.
What?
The second to last step you have,
We're here?
the middle term. How did you get that?
1 times cosine.
Uh,
Cosine times sine.
So you don't want us to
Just
cancel
sine.
that out?
I would not cancel out because you've got a common denominator if you don't.
Okay.
If you keep it, you have a common denominator.
Yeah, keep it.
I'm gonna set up that. So, the middle term again, like.
Right
you
here?
had, yeah, above it, you had 1 over cosine.
That was the secant.
Yeah, and then cosine over sine.
That was the cotangent.
Did you had to get a common denominator?
Not for multiplying.
Oh, yeah, I'm a double.
You're not, yeah, you're not.
Yeah.
Just right here.
If I now this is my next step is to find a common denominator. That's what I'm finna get ready to do. But I'm waiting on everybody.
Are you gonna multiply that right one by cosine? Over cosine?
Yep. Did you get that? Found a common denominator, so I just had to multiply by cosine over cosine. That gave me cosine theta minus cosine squared theta. Which then, these two are going to cancel out. And I'm left with 1 minus cosine squared theta over cosine theta sine theta. Which this equals sine squared theta. Now's when I want to cancel. Going to cancel this one out completely in one of those. So I just have sine over cosine, which is tangent. Boom.
Oh, yeah. For
4 little symbols scratched onto your paper. Yep. All that.
And what is this?
What?
And what is this going to be used in for life?
Lots of things.
what did I speak from this morning?
Hmm. We're gonna do this bottom one. It's gonna be the last one we do together.
Which side do you recommend doing?
Oh, definitely the left. Yeah.
I've seen it too before.
There's a 2. Oh. I don't know what to do when there's numbers. I'm used to all these words now.
I thought we'd have words in there.
All right.
I did think about it.
All right. So first, I'm just gonna get a common denominator. Okay, so I'll talk you through this. This is just distributed property on this side. Cosine times 1, cosine times sine. On this side, I have a minus sign, so it's actually negative cosine times 1 and negative cosine times a negative sine. That's how that right there became a plus sign. That's not, I didn't just mess up. That's why that's a plus sign. And then on bottom, I just FOILed that. But I remember my difference of two squares rule. See, that's exactly the same with just a negative and a positive. So I know it's going to be 1 minus sine squared theta. Because I got my rules. Alright, is anything...
Holler at me when you can help me look at some stuff.
Okay. Alright. Does anything cancel out on this? On the numerator? What?
Cosine, sine.
No. But this cosine minus that cosine is going to go. How many cosine theta sine thetas do I have? 2. I have 2 cosine theta sine theta. Hey, I'm starting to see where they may have gotten the 2. What is 1 minus sine squared theta equal to? Cosine squared theta. Alright, I got 1 up there. And I'm going to make 1 down there. So I have 2 sine thetas over cosine theta, which would be equal to what? 2 tangent thetas. See, that wasn't so bad. Right? Right? I love these things. Alright, day 72 homework.
Well, you said you were Monday.
I think you've got 9 of these.
Is there a day 73?
Lesson? No, like you practice in class. See, it says use the basic, you do day 72 homework, and then just more in-class practice, working with identities. So I have some stuff that we'll go over 72. I have some stuff that we'll do, and then you'll do 73, and then we have a quiz.
No.
The quiz will probably be Tuesday. Yeah. Yes. All right. So there you go.